Hi everyone, thank you so much for coming to this video. So today we're going to be going over some more applications of differentiation. So the learning objective for today is going to be to identify when functions are increasing and decreasing, and to be able to apply differentiation to find the equations of tangents and normals to a curve. So please review the videos we did on differentiation, and how to find the gradient of a curve and how that relates to tangent, and also just go over all the derivatives for the different functions we have gone through. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to. But let's get started. So if we start with this first learning objective, to be able to identify when functions are increasing and decreasing. So I've written out the two different types of functions. So an increasing function is one that curves like upwards like this. And for an increasing function, you have to remember that the gradient is positive. So remember, a tangent has the same gradient as a curve. So if you were to draw tangents of this curve like this, then you see for each of these you just have a positive y over a positive x. That means that the gradient for each of the gradient of the tangent at different points of the curve, they're all positive. So then for an increasing function, you always remember that your gradient is positive. And a decreasing function, on the other hand, is one that curves downwards like this, and it's when your gradient is negative. So again, if you were to draw tangents like this, you can see that you have a negative change in y over positive change in x. So that means you would get a negative gradient when you do change in y over change in x. So that means for decreasing functions, you always have a negative gradient. So let's see if we can apply this definition of what an increasing and decreasing function is to this question here. We have f of x is equal to 4 plus 3x minus 2x squared, and we want to find the x values when f of x is increasing. So try and attempt this question yourself and then come back with a solution. So we want to find when the f of x is increasing. So we want to find why the gradient of f of x is positive. So we want to find, first you just want to find out what the, if we differentiate this, we'd find out the gradient. So if we do f dash of x, your 4, if you differentiate that, that'll just go 0. Your 3x would go to 3, and then your minus 2x would just become minus 4x. And we want to know when this is greater than 0, because that's when it's positive. So then if we rearrange this, we would get 3 is greater than 4x, so then 3 over 4 is greater than x. So therefore the values when fx is increasing is just for the values when x is less than 3 over 4. And that's just your answer to this question. So in order to find out the values of when a function is either increasing or decreasing, you just want to take the derivative of your function, and then if it's increasing, you want to find the values where your derivative is greater than 0, positive. But if you want to find when it's decreasing, you just want to find the values when your derivative of your fx function is less than 0 or negative. So now that we've completed this first learning objective, let's move on to the second one, to be able to apply differentiation to find the equations of tangents and normals to a curve. So moving on to finding the equations of tangents and normals to a curve. So remember that a tangent is just a straight line that touches the curve at just one point, like this, and it has the same gradient as your curve at that point. And your normal is a line that's perpendicular to your curve and passes through at one point, but has a gradient that's -1 of the gradient of the curve, because if you remember perpendicular lines, the gradient of a perpendicular line is just equal to -1 over the gradient of your other line. So if we use these definitions, let's try a question, and we can use these 4 steps here to try and find an equation of a tangent and normal. So we have a question here. We want to find the tangent to the curve y equals 4 minus x, x plus 2 at the point 2, 8. So feel free to try it, attempt it yourself using the 4 steps I've written on the side. So the first step is you just want to differentiate your function. So in order to do that, in order to differentiate our function, we just want to expand it first. So if we have y equals 4 minus x, x plus 2, that's just equal to 4x plus 8 minus x squared minus 2x, and that's just equal to minus x squared plus 2x plus 8 if you collect like terms. So now this is easy to differentiate, so we can do dy over dx, that's just equal to minus 2x plus 2. So remember, you just want to bring your power in front of your x and then do 2 minus 1 of the power, and for this one we want to bring 1 is the power times your coefficient in front of your x times 2, and then you want to do 1 minus 1, which is just 0, so you just get left with 2, and then remember that the derivative of a constant is just 0. So now that we differentiated, the next point is we want to find the gradient of the tangent on the normal. So we're finding a tangent here. So for a tangent, this is the gradient of the curve. So we just want to find the gradient of the curve at the point 2, 8. So we can just plug in x is equal to 2. So that means your dy over dx, that would just be equal to minus 2 times 2 plus 2. So it's just minus 4 plus 2, which is just equal to minus 2. So that's your gradient of the tangent. And now we can write the equation of the tangent in the form y equals mx plus c. So you'd have y is equal to 2x plus c. And then your last step is you want to use the coordinates of a point on the line to complete the equation of the line. So we have a point here, 2, 8. So we can just plug in 2, 8 into this equation to try and find c. So if we do that, we'd have 8 is equal to minus 2 times 2 plus c. And that means 8 is just, if we do 8 plus 4, we'd get 12 is equal to c. So that means we can rewrite our equation as y equals minus 2x plus 12. And that's the equation of our tangent. So it's not that complicated as long as you just follow the 4 steps here, and you just have to remember that for a tangent, the gradient of the tangent is just the same as the gradient of the curve. So if you just differentiate your curve, make sure you expand it so it's easy to differentiate, and then you just plug in your value for x from your point to find the equation of the curve at that point, and then you can just rewrite your equation of the tangent using y equals mx plus c, and then just plug in your coordinates of the point they've given you to find the equation of the whole line. So now let's move on to trying to find the equation of a normal to a curve. We have another question here. We want to find the normal to the curve at y equals x plus 2, x plus 4 over 6 over root x at the point 4, 4. So to do this, the first step is we just want to differentiate the function. So we can do this by expanding first. So we'd get y is equal to x squared plus 4x plus 2x, which is just plus 6x plus 8 over, we can, to make it easy to differentiate, we just want to rewrite our root x as x to the power of 4. X to the power of half, so it'd just be 6x to the power of half. And then using this, we can just use our rules of indices. So if we do x squared over x to the half, we'll just be left with x 3 over 2. So then we'd have 1 over 6 x to the power of 3 over 2. Then if we do 6x over 6x to the power of half, so the 1 over x to the half, that's just 1 minus half, which is just a half. And then if we have 6 over 6, that would just be 1, so it would be plus x to the power of a half. And then we have plus 8 over 3, which is just 4 over 3, 4 over 3 x to the power of half, so we can make that here as just saying x to the 1 over something x to the half, that's just x to the power of minus half. So we get 4 over 3 x to the power of minus a half. And now we can differentiate that. We've made it into an easy form to differentiate. So we can just do dy over dx. That would just be equal to 1/6 over a third, which is just 3 over 12, which is just 1 over 4, x to the power of 3 over 2 minus 1, which is just to the power of a half, plus a half, x to the power of a half minus 1, which is minus a half. And then we want to do 4 over 3 times minus 1 over 2. So that would just cancel down to minus 2 over 3. X to the power of minus a half minus 1, which is just minus 3 over 2. So now we want to find the gradient of the tangent or normal. So for normal, this is minus 1 times the gradient of the curve. So we first want to find the gradient of the curve at the point x equals 4. So if we plug that in, we will get dy over dx. It's just equal to 1/4 of 4 to the power of a half plus a half times 4 to the power of minus a half minus 2 over 3, 4 to the power of minus 3 over 2. And so if we were to plug this in our calculator, we would just get that is equal to 2 over 3. And now to find the gradient of the normal, so of normal, that would just be equal to minus 1 divided by 2 over 3. So that's the same as minus 3 over 2. So that's the equation of our normal. And now if we were to write the equation of the normal in the form y equals mx plus c, so you'd get y is equal to minus 3 over 2 x plus c. And then we can just use the coordinates 4, 4 on the line to complete this equation. So we'd get 4 is equal to minus 3 over 2 times 4 plus c. And then if you were to rearrange this, so first you can multiply everything by 2, so we'd get 8 is equal to minus 12 plus c. So that means 20 plus 2c, so then 20 is equal to 2c, so c is just equal to 10. So now if we were to just plug this into our formula here, we'd get y is equal to minus 3 over 2x plus 10. And that's your answer to this question. So again, it was just firstly rewriting your equation of the line of your curve in easier way to differentiate, and then you can just remember that your gradient of your normal is just minus 1 over the gradient of the curve. So if you find the gradient of your curve first by plugging in your point from your coordinates they give you, and then do minus 1 over that, and then you can just use the equation of the line y equals mx plus c and your coordinates to complete the equation of the normal. So that's everything we wanted to cover today. So let's just end with one exam style question. Okay, so we have an exam question here. Feel free to pause the video and try it out for yourself again. So we have y equals 4x minus 1 times x plus 2 over 2x, and we want to find the equation of the normal at the point when x equals minus 2. And we want our answer in the form ax plus by plus c equals 0. So the first thing we want to do is we want to differentiate the function. So to do this, let's expand your equation out. So we get y is equal to 4x squared plus 8x minus x, which is just plus 7x minus 2 over 2x. And now if we divide each term of our equation individually by 2x, we would get 2x plus 7 over 2 minus, if we do 2 over 2x, that will just be 1 over x. So we can rewrite that as minus x to the power of minus 1. And now we can differentiate this. So we get dy over dx is just equal to 2. Our constant would just stay as 0, and then we'd have minus 1 times minus 1, so that's just plus x to the power of minus 2. And now we want to find the gradient of our normal. So first we want to find the gradient of our curve when x equals -2. So if we to do dy over dx, which is equal to 2 plus -2 to the power of -2, you should get that is equal to 9 over 4. So now if we were to find the gradient of our normal, that is just -1 over the gradient of the curve. So our m of normal, so that would just be -1 divided by 9 over 4, which is the same as -1 times 4 over 9. So that would just be equal to -4 over 9. So now if we want to write the equation of the normal in the form y equals mx plus c, we have y equals -4 over 9 x plus c. And now we want to use the coordinates of a point on the line to complete the equation of the line. So we have one coordinate, x equals -2, but we also need a y coordinate. So now if we were to find a y coordinate, we can say y is equal to 4 times -2 minus 1 -2 plus 2 over 2 times -2. And you notice this -2 plus 2 is just 0. So this whole thing would just go to 0. So now we can say that our y is 0 is equal to -4 over 9 times -2 plus c. So then we get 0 is just equal to 8 over 9 plus c. So then our c is just equal to -8 over 9. So now if we were to complete our equation of the normal, we just get y is equal to -4 over 9x minus 8 over 9. And that's just our answer. So again, you just want to make sure you rewrite your equation of the curve in a way that's differentiable, and then you can just find the gradient at a point they've given you. And remember that for a normal, it's -1 over the gradient of that. Then you can just write your equation of a line normally, and make sure if they've only given you one point to find your other point of y just by plugging in the equation x equals -2, or whatever your x coordinate is, and that should give you your answer. So that's everything. Thank you so much, everyone. Hopefully you found that useful. So just to sum up, we identified when functions are increasing and decreasing, and also learned how to find the equations of tangents and normals to a curve using differentiation. So make sure you do lots of practice questions just to make sure you're really comfortable with everything that we covered.